Good morning, welcome back. Today we'll be starting chapter 18 from our book. In chapter 18, we have two areas to cover. In fact, we'll be able to finish this chapter today. We'll not be able to go through all the algorithms for sort. There are different types of sort presented in this chapter. We'll go through some of them. In this chapter, we'll be focusing on search and sort algorithm. In fact, if you look at your Moodle site, you will see all these algorithms are either presented or some of the animations are provided, which we'll be reviewing in this lecture today. So this week, what we need to do is we need to read, prepare chapter 18. We also will be starting assignment number 4. Assignment number 4 is due this coming Sunday. Assignment number 4 is not going to be that extremely challenging like what we did in the past. In fact, we'll be using search and sort. And I'll make it easier. You can use any search and sort criteria. In fact, we'll be learning about two search criteria into this lecture: sequential search and binary search. These are the two primary searches discussed in chapter 18. Chapter 18 also talks about different types of sorts. These are not the only sorts out there. There are other types of sorts as well, but these are some of the sorts. Some of these sorts are kind of similar. Some of the sorts are they're more efficient. In fact, when I get to the project number 4, assignment number 4, I'll ask you to show your variables, the value of those variables and counters in order to see how many cycles you go through in order to sort your data. All right, so talk about sort. We'll start with sequential search first. Then we'll jump into bubble sort as far as sorting is concerned. Also, in this chapter, it talks about different analysis. Again, that's the same analysis I want from you in assignment number 4. At least show me how many cycles you go through when you are sorting your data. So, and the book talks about different types of techniques used by organizations, by individuals to verify when they're sorting the data, how quickly and efficiently they can sort the data. All right, let's go and get started. So I'm going to start with our Moodle site first. I'll show you if we have a Moodle site and in what direction we have to go through. I think we'll be done with our lecture probably in an hour and a half to hour and 55 minutes. And this lecture will be recorded and it will be available to you just in case if you need to review it. So you'll see on the top of our Moodle site for this week, we have a point, have some questions, answers available from the back of the chapter, some access solutions are available. Also have some files. I'll be using those demo files in the discussion as well. We have some animations. So these are animations. These viewers, you take the animations and sort criteria really simply. Especially some Hungarian universities and Romanian universities, they have special divisions in science departments. They have dance. So we'll review some of these folks from Hungary with the sort, efficient sort. There are other sorts as well. For example, we have sort this in chapter 18. There's also sort I have activated. And here is the number 4. So this is our week, chapter 18. Notice that there are two demo files. One is CP file, one is their file. In fact, I just copied and pasted the book. So this is available to you from the as well. So you take my demo, customize to develop assignment number 4, or you can write your from scratch. Okay. So using these two demo files in my presentation as well. Let's go over some concepts. So in chapter, as stated earlier, we'll be discussing these algorithms. In fact, make large organizations excel these two algorithms. That's so efficient. And according to Google example, the business is search sort. And honestly, search is not very efficient without sorting. If you're searching in a large store, for example, let's say Mart, you're for an item, the item is not sorted properly, it takes you very long to find the item. If it's all sorted by department, aisle, the number in particular aisle, then it's easier to find the item. So your search algorithm, you can do whether a particular item in the list, and be an array, it could be a linked, if it's specifically designed, for example, the location list, exactly data rates, what element or list index of the particular item. Find the option of that item. So we can delete, move it, and so on and so forth. It can be organized in the two ways. You can recognize an ordered list or ordered array list, or it could be ordered array or linked list. So the items, special method that uniquely identifies the item in the set. So you find that item, you find value, you find the name, you find whatever that you're looking for. How do you identify that that's where the item resides, that the name is, that's product rates. So that could subject or it's of element or some other. So comparing the key search item with the of the item in the list. So you do some sort mechanism. You can provide some sort. You can compare with the name at the number of comparisons, and it will do for us number 4. We're counting how many comparisons taking. How times I do these comparisons. Less comparisons means your search or your will be efficient. So simplest search called SQL search. It's really simple. You go start from the after first one, you go to the second, and the third. You go in a sequential manner. Once you find item, you have choice: stop and present that, or you continue search. It's possible you can have same item twice or more times available in this. Same both arrays and list. So the first examine each item. Once it's found, highlight it or use it. Our implementation is some method where we are going to make a decision. What do you want? Do you want to stop after for this found to continue? Times with something on tab, it might say this name or the item 10 times because they stop after first time it found. For example, you're for an air flight, so I want to go for AX Washington D. So they show you multiple flights. They don't stop at the flight, they do multiple their search database. So what we want to probably this thing, you probably continue even after the first time it found. Unless it says to the first time it chose and stop. And then you can analysis. And that's the analysis I'm asking you to do in a site number 4. So analysis means show me how many times you went in the site to search that item. Have countable and just let me know how times you have to go through. ILOOP, execution of the statements is directly related to about the key and how Paris is making. Speed of the does not impact the data have is going to significantly impact the speed or efficiency because the data is very small. At assignment number 4, you only have 1,000 to search or sort. That's not significant of data, very small of data. So in our case, it will require very little computer time. We're talking nanoseconds, nanosecond. But if you increase the size of your data, that will take much longer. And it shows you various ways you can actually, through your analysis, it provides some kind of algorithm, number of items plus divided by 2, so you can figure out how you want to do analysis. Our itself, sequential search itself is really simple. Let me show you what sequential search looks like. Sequential search is what the algorithm for this sequential search is. And again, it is available to you in our file and our Moodle site. If you want to view it on your computers while discussing on, for our online search, you can actually open this and test it. So it's the name of function, name of method, and we will make it generic template. So here's my generic data. It doesn't matter data is integer or some type of data. You can see some kind of array. We can see in the square brackets the in data. This is an array list. I think now we can see in the camel. So it's the name of our this method design turns back to us because we're searching. Want to figure out which element is the index at particular element. So maybe the index I'm turning. So it would be my case. So this is being passed as an event. The length of the list also being passed because method does know what is the size of the list. Are there terms or 1,000 terms? We do know that. So we're also sending length. By the way, there's some methods that even on past test you can fill out. There are some methods available. There are the length of the list as well. And also what item you're looking for. So item you're for. Let's you have data looks like this. The data looks like this. Let me put it over. A list, simple list. We have some here. Notice that it is not sorted any shape or form. Unsorted, unordered. So data is like it doesn't matter change lists to schemes, some products or some customers, whatever. It doesn't really because I'm using plate, so I can change data type. If I'm actually searching for a value or some item, which is 45, I pass value. This is the way I'm looking for. I'm looking 45. 45 is in this list. So that's the piece of data passing argument. So let's look at our function call. My function call is here. I'm calling my sequential function, as you can see here. Because this function is designed to return back to capture that index or the position where that item is found. If the item is found. If the item is not found, of course, I'm going to retrieve that position. The item is captured position here. And then if position was not equal to this one, means it's something, some value to me, such as real index in 5 or 7, something return. They will say item was found this position and I did the positioner. Position the element of that particular list. If the item not found, simply say the item doesn't exist. And then I'm saying, look at I'm passing original list, passing the size, the length list, and I'm passing the number which you would like to search. So I'm asking the user, would you like to search? So you say, I'm search 45. For example, 45 will be passed at particular value. So the 3 key arguments are passing to search. Let's go here, a header file, and that's captured right here. List, the length, the item, and I call item, it's called item. I'm passing as person size. So there's no need to duplicate key. I don't have to. For example, in your if you pass relative rep as a relative reps versus by value, that should work out. And if you by that as well. All right, a couple of local variables. One variable just indicate something is not found. Variable just indicate location of the item. So local variables. And because location is 0, so it will be my starting location in loop. I size, I length given. So I start with the index to all of the list, and so if this is not found. Notice the found is actually false, so this is basically true. And in this case, if it is found becomes true, so if negate it, this will be false. So if it becomes false, it is I will exit from loop. Or the length as I have listed the length of that list. We have terms, I go cycle, and the length of 10 less than 10 because it is being incremented over here. So I go through the test, either this length exhausted or the value was true. Once it becomes true, because the not all becomes false, I will exit. You guys this one? Now this particular line of code is necessary. Left it so you can see how many cycles I grew. This code is one there in the number file, so it will give you how times you went through the, in this list for that. But honestly, part of this thing is right. That's compute the 0th element or the element, the 0th with the first element with the criteria with I'm score. So I'm really picking first element value, comparing my search criteria. Match if you match, it's true. Otherwise, continue in this cycle. Go to 1. Match number 1, item 0, item 1, item number 2, so on. At stage will be exhaust length, full exit. Item not match, input my look, make it 2, make it. Then what I return is return. I check here found true. When I'm checking found is return. The found true, as I from this, I have that in my hand. Return location. Return that location, so exactly at what location that is found in where it was found. The item was not found. Return my item. You don't have to this one. You return any other value. It's just to indicate item was found. No position or location item. Okay. This is really simple. This is the most of one, but it's there. It's not the which Google for their stuff. So in fact, doing sorted sequential search is very efficient because if you search the data is sorted, search way more efficient. Let's say you build item search, and your search the build item, you cycle go through. Build. That's very smart. That's very smart because have data. Let's say that particular data is the mid list. Let's say 500 look. Now, sequential still have to 500 search. There are criteria, search criteria, binary search. Probably able to find much which we'll see in next few. So sequential search really simple. Feel free to sequential for assignment 4. But at the end, the code to you, algorithm is available to you. Either book from site, from inside, all code is available. If these codes change, it's not going to we are going to the algorithm. It's going to exactly identical algorithm. So it's available. So at the end, when assignment 4, when you search something, you search ways. Sequential search as well as research. Search is more efficient than sequential search. So we'll work on which next. Sequential. So what I've done in my file, start sequence, come to my search right there, but provided code header file. You go to header, you'll find research right there. I'm going to define research. Let me go through some of the binary terminal. All right, so binary search. Search can be up to source. This is the criteria here. Search is not for unsorted list. So search really care. Search could be so for unsorted. Binary search there must be in order it could be. Uses hidden technique means middle of list if the data there. That's there's already said, and they say some middle. So you middle and do I match? If I have a match, is the criteria smaller or larger than middle value? And it's smaller value. Accordingly, actually make an addition in and here. So put item to the end. The search is middle risk search to half list. Otherwise, the list for half list. So remember about billion search. If you have a item, if you have billions in case every search, to tell you it will take you a few searches, not billion or not 100 million searches. Here's example here. So this is a sort. This is not sorted. So you apply the research sorted list, and assuming looking for item we have or sorry tell this. So you go and here research. I'm trying to compare. If search item have it is greater, then you move in direction. Search is then you want in this direction. So what you're excluding the list. Okay. You want to say item is searching is this. Go in the main search item. Algorithm really simple. Algorithm is the first. Take the last one. Divide what? The first time you get to the position. The first take item divide two. That you the midterm. So that's the key in binary search. That's the major binary. You do this times you get to information for example for value 5 with 30 didn't. So you got up and then you in this one you take the item again and it will show in the book. You see that item that the list 2 to 10 items. Let's say more than 1,020 items. Take you comparison, which is way less in a sequence search. A sequence it will be higher. So every iteration size search into and in a iterations to find. So even search you can find instead of saying 1,000 times, 100 times. So let's look for again make it larger too. Looking for value. Find that probably I'm not sure, but 870 you can value instead for 750. So save time and much efficient compared to sequential. All here is that research must be sorted. Why can't except for the user website data already sorted? Why can't place the data sorted efficient and these stores Walmart these other stores you go to if not the item in for manner it's harder for customers to see those items. Times by these can I say that item and this aisle number so. And that it's way efficient, especially where we have home examples, millions of different items. So some comparison, and it gives you the says sequential required 112 comparisons compared to after 22 in case of binaries. Save a lot of, and that when large, we are saving a lot of precious in our search. Let's look at the core binary search. These are binary search. So recommend for assignment 4 provide me them. Recommend you the showels in ways or use the item ways. So then in that we actually gone through tried both code. Again we are less with the length in this search what we differential search. Local varies a variable midpoint. So mid we go of the list. So first equals to first is a goal to indicate first or index. The last is minus the length list is 10 minus is baseline. We're referring to index. First is index, length is 9. This is side. Basically, this first side is the last or in those items. So I'm checking if the first is not last, less it's last or not last, and the first is not turned into set involves just date in the one. So there we midpoint. First one, last one by 2. And we go to the point, the list, and pair with middle point, pair with the search. If the match middle point, say it's found. Else, do. This is the guys the key. So that we are doing. So one important. Second one here, there. If is found middle, and see if the middle is greater than this criteria. If that's great, they want to put my midpoint in per half. So here must become middle minus 1. Let's say mid was element. So this becomes fourth end. So last. So I'm seeing my last from the position, fourth position. Previously my was as you can see in this in light. This was minus 1. Last item list. Now I'm shifting last mid one because he compared was not criteria. So I've moved my point of the lower half. If that's the case, the middle was greater to less. That move first direction. Initially it was 0. Now I'm actually my equals to minus 1. So either move your last variable or move first variable. Depend on are you in the lower half or up. It's gonna go back in cycle. And in our case, I would then vary you kind of count to find how many computes you made. And it pick up that 2. The value exists, basically 2, value not found. here, just like what the previous one here. If the value is 5, we return midpoint. If it's not equal to return minus 1, and we can determine our main function here is found or not. Okay? This is simple. At your level, sequential and binary is simple. Uncapped distant data sources. We have to concept. We actually do discuss in CS the class. So if you have in the past, well, we review this once again. So what I do is discuss the sort. I'm going to go through some of high-end sort analysis and all, which I'll do in a minute. But let's see the definitions and terminology for sort. Gives you some, let's say, it shows you comparison make. Why don't you do those comparisons in assignment number as well? If you have 10 items, how much time takes? If you have more items than items, how much time takes in types of criteria? On some of these searches might vary over time, especially if that is not sorted. It also shows you in the format how significant that could be in the analysis. So I'd like to sorting items. So here, the performance of Q sort algorithm provides analysis algorithm. It's the same. It shows you sort versus sort. One is more effective. What from your knowledge? Bubbles the best one. Bubbles are slowest, the simple one. Bubbles the really simple. Bubbles one we have discussed in the previous class as well. Probably have two sort criteria. So again, apply to arrays on list. So what are the bubbles? Suppose your list from 0 index to 10, whatever this list is. In these are minus 1, it is compared as a values. So you take the element pair with the number. If the first view is smaller, then swap them. So in bubbles, basically string happens over and again. Then you take element, the third, if the second is larger, you're referring ascending, first comes, which is that. So you do the comparisons. If you look at the comparisons, they look like this. So if you have a 5 example, just have space. So if you have items, 55, let's say 18 minus 4. So if you have items, compare this with this. This is 0th index, 1 index, 2, 3, and 4. Compare this. If the item larger, swap. This is where the 5 is taking 18 here, and the 5 go there. Then if 25 larger, that's 4 in the next row, swap it. So yes, and it looks bubble. And your bubbles. Okay, I have to show you bubbles ants we talk about. So this is interesting. Put it here. I go through Tahir 10 minutes, at least part of it. So let's one. So I'll bubble it. And version and capture. So for unsorted get, as you can, data will be fed. That's our data, and you can element this. So the first swap place. On instances to the contents as well. So here, on this is bring the value, bring the value at the so is not just any in some animation. See the components number of it goes and to look at the animate bunch of it out there. People stuff variously. There is some items we are on the end. They should not swap here. The comparison, but they swap here. So they are, that's our fit that way. All right, goes to the same cell again. All right, so the board is simpler as you get. It's a sort, not the motion one, but the one you are not large data and just want something really simple. Sort is the whole idea. One compared the two and swap. Really simple. I'll turn this out. I think I was 30 years. Now have changed a bit, I'm gonna check us how it's a really so all right. Let's look at rhythm again. By calling a program, I'm to the main first in function here. I'm calling and I'll sort all type sorts in them as well. By calling my board, you can see I have some sort, and I have sorts, and I have provided on our web as well. So I'm list and side. Because I start searching, I'm saying, and when I'm done with about my data, my list should be sorted. My list should be sorted. Okay? So if you feel that you have to keep a rich list hand as well, then make a copy of your list. Copy to the bubbles. Just if you feel though you have your rich list without making manipulation, make a copy. Here I'm not going to copy. I send list, and on this list, it's an array. So array by the path reference, which means once is sent and it's manipulated, I can't do it. So if I have that you the original copy instead of copy. All right, so send to my function, my bubble capture here as it's a I can size or length, and checking the second element. When I'm starting second element, checking the length. What is the length? The length is the size is 2. And check 0 to x and is 0 than 10. For example, this is 10. 10 because the is size, but x will be 9. 10 is the size of the index. Last will be last element 9. Checking 0 less than, and checking if my index element is greater than element. This is my index plus 1. So if my element, which is element, it is 0 index, is greater than the next element. This is heading sort. How do I do descending? Change here. If you choose the symbol, it will be descending. So what I ask you, why don't you for assign 4, give me both. Ask that you want a sort or desort. And you can just copy this code, switch to the symbol, that will be sending sort. So it's really
Just last one thing. What's like a number compared strings?
So it's architected. So set the value of a character. So you have Mary, so compare, and so on. So it's compare, and it's paired with the problems because it's in the back compare the values. And this part of sort. So you have to review if that's true. That's true. You want to run to the value. So you want this to 18. Let's say it was greater than 25, greater than 18. So you want to observe 18. We are doing here is we are preview. We are saying store 18. See what I'm doing. In this case, I'm this value. Store either value, this value, one value. If you cut to the other option, you observe it. So this other value is 25 in this case, forecast. That would well. So then copy 8 to this location. That's what I'm doing here. This is my 8. In one is the element. Copy to location. Then to this location is this value. I would like my 10 locate view and this location. So that's through this over and we see in the end as well the definition that's what comparing first they were swap. Okay, this is the same you will use for Java as algorithm or Java as well. If you decide you just want to sort the number for USOs, but I'm telling you that try a couple of things as well. So before I do other thing, let me direct the book talk about a speaker, or then we'll come back into the other criteria. Let's see if I can. So to see which number, assignment 4 is on 35, 1345. And number 15. Okay. Number 15. All right. So assignment number 4 is write up that create 3 idle arrays. One lists 3 elements, 3 idle arrays. The pro sorts using sort, using sort, and using entry. That's good. So I'm making 3 of them. So that just doing one. I was asking if you can try sort as well. That's what you to show me analysis, which was more efficient, and maybe paragraph. TXT file or in your section, your analysis sort was sufficient. Why? Say, oh, my selection sort is more efficient. Somebody else says, you know what, my sort is more efficient. Tell me why. So analysis. So, well, how do I? Well, it's already on. It's already there. You just implement and you say, how do I find 5,000 elements? Help me out. How do I get values as an element? How do you 5,000? Ask the user 5,000. That would be inefficient. Read the text file, still that's efficient. So how do you get those analysis? How about renderer? RA function, reduction. Well, I don't know how to do that. Well, an RN and parenthesis and close, and simple C plus A and function, and it you how rate value any size. It's this one. You can always C++.com. It's a provide you tools website. You don't have to go to the site. Looks like it's kind of for some reason, but here it is. Of values values, random value in, let's say, random, or this operator, 100, it's going to generate random value 0 and 9. How did a value between 0 and 1? Help me. If I 0 between 99 using plus 1, how do I between 1 plus 1? How do I between 0 and 1000? Plus 1000. So you can loop that one, generate a value, plug value or value into the list. It's for loop, and it's going to use the list. You have to be a user or have a text, that will be inefficient. So, and it is really simple. Something is, let's say the value you're generating. So you can say R&D modular 510. So it does, it's a value 0, 5,000. You have to have 5,000 if you want 1,000. Right? You can make this larger, it doesn't matter. What it does, it's the value at range. And once view is picked, you want to put you in your place view in the first and second, and increment that every time for that value. So that's how to do for assignment number. You show here. Use these sort criteria out number of presence items assigned by each algorithm. One more thing to do in this. I also search. Those who have been have that out is the most fun. Let's say use what would you like to search? If that exists, provide me. And I want you to both search areas, seek search and binary search. So show me the increase. Show me sequential search. How search is it do as compared to research? Is an analysis in SQL. Okay, I'm going to mark my assign. I'm going to what I did here. So very clear. Looking for search, seek search, binary search. Looking for analysis. And please some kind of maybe text file in the submission. You upload Moodle, which we found efficient. After the answer. The answer I just find through algorithm. Now you have more. Say out. It wasn't because you get code. I found I selection and version. So I'm going to step for try merge. If you add that would listen. Or go keep sorting. Otherwise, you just material you go. Other process, this one, the for 60 and so forth. Okay, so your full sort. What I demonstrate shows you right here. Shows you all the cases. When you look, it will be here. Then shows you something that says how the iteration provides kind of equation to find out what compatible. Actions. Finish list selecting element and to the position. For the smallest, for example, or whatever method, let's say for smallest to the big of that. Can also try to list. So if you decide I'm going to find smallest list, I go through the line the smallest, get to the in the big list, and then it use. So if it has give me out here kind of view here. Let's see if we can get some sort here. The selection, I'm setting list. Let's generate view, random for example, number 4 as well. Check what I did earlier on. See running 0 tests of the length and loop and there. Set my swap. The swap is taking place. Now if you do a here, you can create for swaption both ways. So I have a function to you. If you have to type code a single swap, you can call swap function. So I actually commented, but function available to you the swap right there. So for your port, even select port, you may call swap function if you will, if you want. Guys, just swapping place. We'll talk about this in a second. But that's what we are saying. I'm going to hold the value in a location. So I swap minimum location and temporary put in them. So basically, thing is takes. Nothing else is here before. So I'm calling the function location trying to find out minimum the smallest value in this case. Or I can find the value. Say I'm trying to smallest value. So I can decide to say, okay, I'm going to pass the location 0, the element, and minus 1, the list L. Because my is to find minimum x, so find minimum location, minimum location. So location basic turn the index, smallest x, index smallest, and my left is my first value, 0. Here is the value of the last left size. This will mean. I'm assuming item, the value, the first is the I'm assuming one. I do this one from the next, which is number 2, till I match the item, I pass item. The pairing, first item, then 0 value. First is value, location, my location X value, my first value, or look in this case, the first element is less than the minimum. Honestly, this comparison is with myself. Let's compare. The next goal, go to the next goal and bring the next. So my find the index smallest. And if I find this is true, this value less than the next neighbor, then we'll put this look in index and we'll return minimum index. So I return minimum index. The minimum will be put in this index. And that's what I do, my select criteria. So in select sort. So trying to find location of through this and over again as the data be compared. So select one way to look at it. So you're going through the swapping mechanism. You go to thing. Again, when you are this sort of actions, if you're some time and you're less complex one, that would be for us before as well. And tell why the better sort. Much time, how many cells duration saved in this case. Look at the third one. We will not go through all. We'll be going a bunch of comparisons as well. Provide you that let's insertion. Yeah, insert sort sorts by moving each element to proper in the position of the list. So here, this list, the half of the list sorted. Last list is sorted. So till 10, 85, they're sorted, and part of the list not sorted. So I just sort by move each at its proportion. So when 23, when we these two pairs, we notice 23 are a sorted location. So take out 3, somehow again 20 in these terms. So insert that insertion. Insert the item in a place. I think it has graphics show, and yes, it does. So sorted list is my unsorted list. So where 20 need to be in that location. So then I put my over here 25 here. This analysis that this coefficient is to add an, especially in our here it's putting 3 in 3 look. Don't lose. Try copy over here, which I next side. So I'm copy to the this location, move 20 to this location. Literally insert right there. And 3 being moved, and here. Let's get a demo in this. Forgot to select sorts. That's okay. Let's move on to insert. That's the first one. Okay. Notice this is difficult sort. So paired with us. We are going to this swap. Same thing happens. We've continued in that. So the half is altered. Focusing on sort area. No more completed because 3 already small 5. They will compare to this pair, but happen. Folks, you get an. Now, what if we create in our case, give you now to part of this. Are you interested? Universities that seriously through main force. So we take it deep. These anybody has a friend, Indian or friend, they are good in sciences. Their university really in these Indian UTs, Indian, Hungarian, Russian UTs are really in computers. So they this stuff seriously. So the special fits, all the nut signs. So I'm assuming that RD are sitting geeks out there. They're time lives. So joking, but there are a lot of courses. There are folk dance, there's a Indian dance, there's a sword. I think the Americans, see, these are in G. So many of here I doing sections, these numbers here, color court and Yukon and all. Here's the spells too, and I guess looks like a. Can you tell which is this? Can't tell. One of the Scandinavian language or Yukon. There are a lot of things I've done. Learning sleep. On. So we were talking about insertion sort, discuss the insertion. I'm going to show insertion sort I. All right, insertion sort have here. So take a look here. So place, second place, I length, and here's my first order, and length and all the way to, and first order plus. I'm comparing my first element. It's technically the second element. It's first element because we are looking at A1 in its basic second element. Second element is then the element. This is the element. Here I'm order which is 1 minus 0. So I'm comparing this and the second with the if less, hold on to in the location, and first order is the loop. Go through a while loop. You can use a loop or some other loop. While is because the first if the location is 1, and that's what we have look 1, and copy to location 0, location 1. Swapping. I'm saying in this a 0th element larger than the first element, assume 1. So that's moving them, and location is minus in the location. So I decide over and over. So that goes in sort. I think the last I want to show is I want to jump to merge the code. I'm not sure I included one in the merge. I would like to show a graphic merge. Here it is. Interesting. Sort is interesting one. But here, let's just see if I can larger. I think that's our list. This is my ordered list. This 10 member 10 million doesn't really. What you want is you want to do it over and over. So let's say 1, 2, 3, 4, 5, 7, 8. I want to divide this list to 2 parts. Take this half, 35, 14, 40 right here, and take the list here, and divide. So we have 4 member divide. We have 37, 20, 18, 5 here. Nothing here. You are left with 2, 28, and now here compared is 35 and 20. Is 35 less than 28 or 28? Here it. 35 greater than 20. Swap and put it to list. So I swap it and put this new. I did think here was no swap place here. The same here. Swap it is here. No swap place. Do the same thing. This list is sorted. This is a sorted. Do the compare. 8 and 18 is then 20. So merge or you merge. You do here if 8 is the value line. This otherwise swap them. So you're basically writing to the first level. You are the neighbors and put a new list. You take the next set of others pairing with the same thing, and you will the new list right there. This new list started with sorted. Here is sorted list. So we start something which is sorted. So the other technical. What technical and Twitter and Amazon and all these things use? I don't know. They were in universe. Google Codes. Those guys found a tech that we is wonderful. We have to wait to get out of it. They have left the degree. This is the history. $100 billion each $40 billion because of the tech which has to switch and sort. Search by itself is less. Search has to sort. So search they are hand in hand, married to be separate. So must have correct sort criteria in place in order to. So that's the before go. Do you remember any browsers or engines out? Yeah, Ask Jeeves, Alpis, Yahoo. They depended on anything else. It used to be Sen. They used to be bankrupt, but there were many other cases, and go looking over the searches. So that's there. See a business and sort. Looks like a business search, but basically it's in everything in the source. So for this, it would be find most and sort. Put some analysis to show that 3 sort we have. So add the search I'm asking you. So we should to find the data for. And again, asking you to generate data. Generate the data. Have little one you can use the size, but randomly 5,000 of data into your attitudes, and then and see how quickly you can actually close. Quickly you could and how you can. That would be here. This is easy. This is way easier than the previous chapter. Our following chapter. Let's look at your 19. Chapter 19 is about trees. So we're spending more time. I think we'll finish in 1 hour that we can have. We'll be spending a little time on binaries as well. Once we are done for 18, hopefully done this binary next Monday, next week. that our goal would take an exam based on chapter 10 and 19. Are not this material, a couple of weeks we take second exam. Go ahead and start being prepare the chapter. All right, so I have that today. Right, the topic